Let's see. Okay, it should be fixed now. Great. Okay, so sorry about that. First time I'm ever doing a live stream like this, so might be some technical glitches. Again, feel free to say hello in the chat, so you can see that you're here. I guess I'll be talking through some things that or things I'm doing, and you can of course ask questions. Otherwise, I'll just basically be doing the work I need to do. What I'm going to look into today is loading APL code on demand. So we quite recently added a system that allows you to put APL code in text files in certain locations, and then when APL starts up, then things get loaded into Quad SE and lives there so that you can access them. And so I use this, for example. So if we open up here, documents and dialog APL files, and I have something called startup session, and it has a bunch of stuff that I've organized into directories, and then we can see that there are some, for example, some utilities in here. They're all sitting here. And every single one of these files is then an APL function or a scripted namespace or an operator and so on. And then what happens in here is that if I go into Quad SC, let's make this a bit bigger for you. Then such a directory utils becomes a namespace in here, and then I can see all these things here. But that means that my session then is flooded not just with names but also with content. So I bet I'm actually using quite a lot of memory for doing nothing. We can have a look. How much memory does APL use doing nothing? So I have a clean workspace just started, and already using 90 megabytes of RAM. Really, it shouldn't use so much, I guess. We can maybe look at what's there. Quad se dot quad nl -9. So this is a list of all the stuff that's in Quad SE, and then we can get the quad size. I can do this inside Quad SE. Can you take a name list? Yeah, so these are all the byte counts. Okay, yeah, so Roger GS says that his dialog is less than 12 megabyte, right? So we can see that I'm using just these references alone there are using 5 megabytes, and then each one of them contains lots of stuff. So if we take one of them, utils, we can probably see that utils uses another 100 kilobytes and so on. So every one of them is going to be some memory, and the idea here is that it should be able to load in things. So an easy way to do this, which I'm not going to do, would be to create an operator which takes a file name as the left argument and derives a function which is just whatever is in that function is in that file. So then every time you call this derived function, which is just the operator with the file name, it would go in and read that file in and then and apply that. But there are a couple of reasons I don't want to do this. Firstly, it's very simple. I don't need to experiment with it. Another reason is that it won't work for operators, of course, and it won't work for arrays either. And lastly, it kind of breaks the nice syntax of APL. So it would be nicer if we could just go into a namespace, say for quadec.load on demand, and then we would actually have the names in here with auto completion, and we can apply them directly. So that's what I'm going to try to do. I'm going to try to do this in two different ways. The first one, I'll just do it for functions, because I have a trick there that I can use. And the second way to do it, I'll try to do it for everything. And so the trick for functions is that you might not know that um, a threadfin can return a function. And so my idea is that I'm going to read a directory, and then I'm going to I look at all the function names. Then I'm going to create stub threadfins in the namespace that just have the same name as what I can infer from the file name, say from this directory. And the stubs will all be basically identical. They will go in and do the loading on demand. There's also a design question, which I'm not really sure about, which is, should we load the function in every time it's called, or should we kind of cache it so that when it's loaded in, it takes the place of the placeholder, and then we use it at that point? Or maybe we should load it into somewhere else and call it from there. But there's some cool tricks you can do for caching. Actually, it's really easy. Do it in a line or two. But today is not a tutorial in doing anything. I haven't tried this before. I've intentionally waited, so this is completely from scratch, a new thing, and I'm going to experiment and see how it turns out. Simply. So the first thing I'm going to do is let's create a directory that we're going to use for this. Okay, and in here I'm going to create some text files. We could do that in various ways. Maybe the easiest way here is to create some content here. So let's say quad ns. So it's a load on demand namespace, and I'm going to create a foo function, and the goo function. Actually, right there. Yeah, and rack 1507 says yeah, he's going to ask about caching. Yeah, but we'll look into that. Maybe let's create an array as well. The question is how we're going to store arrays using array notation. We can come back to that. Let's do functions for now, like that. And that's probably all we need just to test it. Okay. So link export, which is just to export load /temp load. Source is in the namespace. Oh, yeah. Source. Huh? I thought I could do this. Maybe I don't even need to specify. Oh, I'm using the new link. I forgot about that. This is a new link that will be released soon, so it works a little bit differently than the old one. Okay, so we've got the two files here, and we can clear our workspace. So we start over from fresh. We can create a new namespace to load these things into. So load on demand function. Let's see, we're going to take a path. Actually, yeah, we probably don't want to do a path and the namespace, and that's it. Maybe we want to return a status message when we're done, just for good order. So we're going to do quad n info on the path, followed by star dot. Yeah, we just do it like this for now. It's good enough. And we'll do wildcard, I think it's called. You can look it up. Wildcard, the principal option. Aha. Let's do some code golf. Okay, and so this gives us our list of files there. We can we can even try this in good APL order. Temp LUD, and we want to do into the LUD like that. Let's see. Ooh, yeah, of course, I forgot something. Needs to be a slash there. Okay, so that gives us that. We need to disclose that because it could return multiple things. Okay, and then we want to know what the names are, and so for that we can use quad n parts, and we just want the second element of each one, like that. Okay. So those are going to be the names. Okay, and since I'm using pick, I better be localizing quad.io good order. Right, then we need to create a stub for each one. So let's go design what a stub will look like. So the stub is going to contain the file name. So yeah, we can go over here, get one of these. So we're going to have the file name there, and it's not going to take any arguments because we want to return the function right there. And we'll do that with the name itself as well. So we can try it for this one. It's going to be called foo and return a result which is foo, and that's going to be that function foo right there. And so we're making assumptions that the file actually contains what it claims to on the can. We probably don't need to support anything else than that. And I think the only thing we need to do here is to define it. So I think we just do a quad fix, the two quad fix, because it's a functions and file colon slash slash like that. And I think that's it actually. I'm going to try it, see what happens now. So this is going to fix the file, it's going to create the name foo, it's going to overwrite this value foo over here. Well, not overwrite, it's going to return this value foo here, and that's it. So let's see. So this was stuff is called foo, and we defined foo up here to be this dyadic function. So we should be able to say 1 plus 2 times 10. Hey, look at that! We just implemented it in like one line of code. That was easy. Okay, so if we take this stub, we just need to create a function that looks like this. So we want to say for name in names, then we want to create something like this. So we say name comma name, and so we should be for name and file in names and files, each of those. And the second line is going to say this, to quad fix, and then a quote followed by the file, and we need to remember to put in file colon slash slash, and the file name, and an ending quote. And then we need to fix that inside the namespace. So ns.quadfix, and it's a function. You need to make sure to do a 2 over here. Yeah, we are streaming, as Roll the Time says. That's it. I mean, we can clean this up afterwards to make it a nice defen and with an each or something like that. But just as a prototype right now, this would probably work. A nice thing about about, yeah, there won't even be any name clashes here. Okay, so let's try this. So if we say load on demand, ns load on demand temp load. Ooh, what happened? Oh yeah, no, of course not. The namespace load. Ta-dam. Okay, so now we've got foo, and it looks like this. Look at that. And we've got goo as well. "1080p buffering heavily." If I understand it right, that just means your connection is not so strong. Can you not ask for a lower resolution? I suppose I don't have to send out a lower resolution. Okay, that's load on demand right there. That's a simple one. Oh wow, that's weird. That you can't ask for lower resolution. Okay, so this is a load on demand, the simple one. Okay. So RickyDB says that you can quality is auto or 1080. But who sets that? Is it not the viewer that can choose auto? And if you have a slow connection, it should scale things down. Oh wow, Twitch only has resolution options for partner streamers or whatever. So, do you want me to lower my outgoing quality so that you can see, or? Oh, that's silly. Maybe I should use YouTube or something, or just make it a Zoom call. I mean, I guess we don't really need that high of a resolution. Yeah, and unlikely I'm going to have over 200 viewers, so I don't know. I mean, if you think that I should, if you think that I should do, can I not just change my my video quality on the fly? Maybe not. Output stream. Ooh. That's a bit rate. Video. Download more internet. Yeah. I think if I stop my video for a moment, I can actually change it. Really? Is she restarting the stream? I don't think so. I think if I just stop the video feed for a minute, and then I think I can change it. Let's see. Yeah. Any outputs, video outputs currently active. Okay, fine. No, I can't do that. Okay, so video is back. Well, next time I guess I'll do lower resolution. Sorry about that. Okay, let's look at the more advanced load on demand. See, the problem here is that if we create a an operator, so if we hello Peter, welcome. So I'm going to create an operator here, and let's change that to actually be an operator as well. Oh, where did that go? It's right there. Okay. So now it takes a function foo right here and returns a result, and then we're going to apply the function foo on each of x and y. For example, just say if 0 is a member of the tally of each of x and y, then we return something, then we return y. Otherwise, it doesn't really matter, right? Okay. So now if we try to do this, this load on demand, so now we have LOD and we've got this up thing, and the problem is it's going to try to return this as an operator. So now if we try to actually use it, then we're going to oh wow, yeah, this didn't work at all, right? And that's because it tried to run this and try to return the operator, and yeah, it's something, it didn't work out at all. Anyway, so yeah, that doesn't work. So that's a limitation here with this simple load on demand. And now I'm going to see if we can do something more clever, and that is to get the signature out of everything. So we're going to start off the same way. I'm going to clone this load on demand, and we're going to make it more fancy. And then we're going to temporarily load in this name. So I'm going to actually we could probably start it by loading them all in. So we say to ns.quadfix file colon followed by the file name. Okay, and now I need to find out what is the signature of that name. So this returns. Now I don't need to worry about the name of the thing anymore, because I can actually I can infer that from the content of the file. So we don't need that. And so this is a more safe way, just in case that the file name doesn't match the content. So this returns the name. And then we're going to replace it with the stub. Okay, so we can again go and look at what should the stub look like. So for a function, oh yeah, of course, this didn't actually work. Erase. It doesn't even matter. Get temp. Get is a user command that I've written to allow you to get anything from anywhere, basically, and it should be shipped with, hopefully, with the next version of dialog. So this gets foo. So the problem here, of course, is foo is a defen, and defens are basically ambivalent. So we need to replicate that. We need to create a header that can handle this correctly. So let's look at what that could look like. So if you want to write it as a thread, which you can do to begin with. So then we have, oh, that might be a problem with shadowing names. Okay. Oh, but we can't decide on. We want to make it a defen if it's a defen, a threadfen if it's a threadfen. That would be nice as well. So basically, what we want to do is we want to just take out everything other than that shell, and then copy it in and call it again. Okay. So what we want to do is we want to have foo like this, and then we want the file name of foo. So that's temp load foo.aplf, and we want to fix that in place here. So to quad fix on file colon / here, followed by the file name. And then we want, so after having that, therefore, of course, if it's a defen, we want to sync that and continue execution. It's a bit annoying, but that's what we got to do. Then we want to call it with the arguments that we were called with. So basically, normally we would do this trick like this, but there's actually a downside to that, because if we do that, then if it's shy, then we're going to coerce an argument out. So what we're going to do is we're going to say if the left argument is an array, then we're going to call it dyadically. So then we say alpha, and then the name of the function. Oh, okay. So we could really use the name here, or we could. I mean, we know the name already. We know the name. So foo omega, and otherwise just foo omega, like that. I think that will work. We can try it. Okay, so 1 and 10. Yeah, that works. Okay. There might be a slight... Oh, right, and it replaced itself. So I just lost the things that I wrote, but that's okay. So this actually would take care of the caching, right? So this would automatically overwrite the current function using because it's not shadowed. If you want, okay, so this would actually, yeah, this would load it in. If you didn't want that to happen, if you wanted to load it every time we use it, then we just have to localize that name before we call it. That's okay. So let's see if I can rebuild that thing. So the first thing we want to find out is what type is name. So we do quad nc the enclose of the name, because that will allow us to find out what exactly it's going on. So select that and case, and we're going to have a bunch of cases. So a traditional function is 3.1, a defin is 3.2, a d up thread up is 4.1, and a thread up is 4. Sorry, a d up is 4.2. Okay. So then we can do it piece by piece. So and we can build the source little by little, and we can always combine it afterwards. So we're going to start off with the name, followed by the assignment arrow, and that's going to be our first line. And then we are going to create a bunch of these. We can even make an option now whether we want to cache or not, but whatever. Okay, so we wanted to have quad fix file colon slash. So we need to be a 2 quad fix there. This followed by the file name and the ending quote, and we wanted to do that. Alright, so here we could actually just insert the name. Okay, that would work. And then we wanted to say if we have a left argument, then we call it with the left argument. So this followed by the name and omega. Otherwise, we just call it monadically. So just name followed by omega, and then close it. I think that's it. We're done basically. We can get rid of this. Okay. Before I start losing anything, let's make sure that we don't. Okay. So let's get rid of flood, and then erase. And we probably want to save these. So let's put them into link create hash and load on demand. Okay, now we're not going to lose those. Should we try it? Sure, we can try it. Why not? So let's make a new namespace. load quad ns, and then load on demand, and we wanted to get right from over here. Ooh. Oh, hold on. What is name? Foo. I made a mistake there. So the name class of that. Oh, it's already enclosed. Why is it enclosed? Oh, because quadfix returns a list of names, so it's already a single name like that. So what's the shape of this? It's a vector, right? That's the problem. Okay, so yeah, that's probably the best way to do it. And another thing I forgot to do is we need to check the name class inside this. Okay, so it's a 3.2. We go in here and we build the source, and that looks sensible, doesn't it? Yep. So that has the same signature. So then the last thing we need to do now is just to replace the current foo with the placeholder. So we say ns quadfix source, like that, and that should have written it over. Actually, you just go out of that. So load foo, and we have the placeholder there, and then we can run it. There we go. That works. Great. Now we just need to fill in the other ones. We can probably do that by heart. Just copying that over. So for a tread up, it's a bit more interesting. Let's do a tread first. We could actually create a stub one. So we've got this guy. And what do we want to do here? We basically just want the header, don't we? We can just copy the header. Cool. So here we can say that the source is the first element of the nested representation. For that name. And that's right. And then we need to do the same things as we did before. This is interesting. So we'll do this quadfix again. We don't need to sync it in this case, it's shy anyway. Should I have a good order, just so it looks nice? Do this. What if the header of the transform spans multiple lines? Asks Roger GS. Yeah, header itself can't, but it's a good point. There could be local lines on additional lines. So, for example, I could put this down here, but that doesn't matter because we only need the header for the calling syntax, and we don't actually. We're going to write this over. What doesn't work if you use the previous Treadmill stub? Well, this is not a Treadmill stub. This is a defense stub. Would it work to use a defense stub? Well, there are a couple of reasons I would want to use a Treadmill stub also, because that would allow other tools to look at what is the calling syntax and what is the name class of this thing, and it will match what it will be after we do the load on demand. But I guess I could use it. Technically, I could use a defense. So the head multiple lines of a header is not a problem because we don't need to localize at this point. We will do that on the second time around when we call it. Oh, with returning a function. Oh, right. Actually, for any function, what you mean to do is we could do this one, this stub. Yeah, we could do that, but the problem is, I mean, obviously we can. We already implemented this. But the thing is that again, it doesn't get the right calling syntax. We're going to return a function in this instead, and I'd like to implement now the other way around, where we actually duplicated it. So we take this and then we replace it with the content of the file, and then we actually need to call it again. So if we look at goo, how do we call goo with the right arguments? So think about it. We've got the same header, and then in here we want to call goo, and that's actually just the header again. So we just called the header, and that's it, and it's going to assign to the result variables when we come out of it. And that's it. So I think that's all we need to do. So we can actually be clever and just say this followed by source. So we're adding this, and we're adding one more of the first one as well. I think so. Let's try it. So let's see. We were doing. We have it up here. Okay, so and then we should have foo. Foo looks fine, and goo. Oh. Hold on. What happened? Did I change goo? I thought I had. Oh, this is goo. That's not right. Let's see what happened. Let's step through this. So the first file, we can probably just hover over this. Okay, so this is foo. It goes in here. It creates this. Oh, I know what happened. I forgot to fix it over here. So we can actually do that after that. We just do it in every case like that. So we fix that, and then we do this one, and we can have a look at what it looks like. Oh, that looks weird. Something's not right with the nesting levels here. Oh yeah, of course not. Like that. Okay, so what does the source look like now? Now, what if the first line has localizations? Yeah, that's true. Good point. Yeah, it will have localizations in the stub, so we need to just clear those out. But we know, very good point. Thank you. We know that there will never be any semicolons in the syntax part of the header, so we can just chop those out. In fact, we don't even need any localizations at all here in the source, so we can just do that right away. So, thank you. So any semicolon followed by anything, replace that with nothing. That should do it. And this gives us our source. Yeah, operators are going to be a problem. As RickyDP is saying, we can't just use the thing where we return it like we did before, because operators can't be returned from a Treadmill. It's a hack to use that. But this looks good. So we're going to load that and run it, and okay. And now we can try it. So to use goo here, if we have a look, what does it look like? That's that stub. And then you run it, and it ran. And now if we look at it again, it has been replaced with the actual source code. No, I wouldn't call APN an esoteric language. It may look esoteric to those that are used to traditional programming languages, but APL is actually used by like big companies to do real work, both making real money and doing important life important things. So no, not an esoteric language. I mean, would you call Chinese an esoteric language? Just because it doesn't use Latin characters? I wouldn't. Okay, so this worked fine. Now for the operators, I think we can do exactly the same, actually. So that means we can just make this a case list, and then it's 4.1, and I think we can do the same thing over here. So that means the only thing we really care about here is the fractional part. So like that. So actually we can just make it an if, I guess. Well, it's interesting. What happens if it's a namespace? Yeah, so maybe we won't do this just to be safe. So case list that and case list. So if later we come back to do it for namespace, better have it ready like that, because there could be like. So what if it's a 9.1 and a 9.2 and a 9.3 or whatever they are? I think 9.5 something. It's classes and instant and interfaces and stuff. I don't remember. Let's see, what are they? Namespace, not an instance, they will never come in, but 9.1, 4, and 5 are the important, those that we need. 1, 4, and 5. Those are objects. And that's, we probably don't need anything else. Okay, so I think we've got the load on demand. And so as opposed to the other one, where yeah, this one is more solid. One thing we could also do is we could look at the size of it, because really, why do we not want to load this in the beginning? We are loading in everything anyway, so why do we want to erase it? That would be to save memory. So if the whole function is smaller than our template, then there's not really a point in trying to load on demand. We could just load it in. But hey, or maybe it doesn't matter. The difference is so little. It's so little code anyway. And so the benefit of this, yes, you're right. Case list and case list. I need to change that. Thank you. Benefit of this after we run this is that if we look at what's here, so already now we can say what is the name class of this, and we can see right away that it's an operator. And if we ask for the attributes of it, so then we can see what this means is it returns a result. It's a dyadic function derived from a monadic operator. Whereas if we use this way to load it in, then we can see we get the different attributes. It says, yes, it returns a result, which is the function itself, which will fail actually because it's an operator. It's niladic and it's not an operator, even though it's actually an operator. So this load on demand 2 allows us to use code to analyze what we've got. Cool. Yeah. No. I think this can work. Should we do it for namespaces as well? So for namespaces, yeah, this will also allow another thing. Like if we, so now which one did we run? We run this one. So if we use the Workspace Explorer, and Ride has something similar. So if we can go in here and look, and then it has these little icons, and I don't know if you can see, it's tiny, but it has a little blue F. It means it's a function. So we can go in and look at them. Oh, hold on, this is not the right place. Yeah, so go in here. See, they're all functions. Even the one that's an operator is a function. And when we look over here, description, it doesn't show what the actual calling syntax is. But if we use this load on demand 2, and then we go and look at it, so then we can see that we get the proper syntax description in the Workspace Explorer. And if we open it up here, it will also, it can also, it's really tiny, I'm sure, but it actually says OP here, so this is an operator, and these are functions. Why is this one a function? Oh, because I never changed it to be. That's okay. Anyway, you get the idea. So you can see it's really useful to have the calling syntax there, the type there. In Ride you get these nice big icons, that colorful icons that will tell you what type things are. So this helps a little bit, and this also allows me to go in and say, so even though I've just loaded it, I can go in and say, in here, what are my functions, right? And what are my operators, like that. And it wouldn't be, if I do that here with this one, then we'll get all functions and no operators. So we can't even use the development tools that we've got. So I definitely like this one better. Okay, there's plenty of time. This went really quickly. Let's do namespaces as well. So namespaces are a bit interesting. Yeah, I know the array editor. It's old. It doesn't. We're just holding off a little bit on replacing it because we just want the array notation to become established. At that point, we can instead of trying to edit it with this kind of GUI that does a somewhat good job of displaying an array, you can just let you edit the array notation and then and then run that. And I know, yeah, it's prone to crash dialog right and left. It doesn't really follow into the century. And if you look at the language at the menu bar of the array editor, you also find that the icons there, they use quad ML3, and that's just how it is. There's no way to change that, so it's outdated. Okay, so for namespace is a bit interesting. I'm a bit worried about classes here. Here we can't use a stub because there would be no way for us to return anything when you just reference something. So we have to replace it with a function. But basically, we could do something similar as that old thing, as this one, which is just to return whatever it is. So I think I'm going to just throw that in there. So the idea is we fix this object. Oh, then we don't want to return the name. We want to return a reference to it. So the header is going to be the name, and it just returns that thing. Oh, no, that's right. So it returns that. This will establish it. It creates a ref, and then yeah, I think that works. Let's go create one. So a new text document. There we go. Real programmers use Notepad. Namespace, my namespace, var is 42, and fin is that. Actually, let's make it that. And namespace. There we go. Yes. Let's change that to an APL. And it doesn't actually matter here because we just looked at all the files, but that could always be fixed later. Okay, so let's try to load on demand. Oh, that didn't work. Oh, what are we doing in here? It couldn't fix the function. And why couldn't it fix the function? Well, let's look at what the source looks like. That's interesting. Oh, I bet it couldn't do that because that would require it to. No, hold on. Why is that not a valid? Can we do quad fx on that? No, that works. 2 quad fix. But this doesn't work. It couldn't fix function. Oh, that's a helpful message. Do we have something in NS called myNS? Yeah, we do. Oh, right. So this is the problem. So myNS is already we just loaded it here, and that made it into a namespace. and you're not allowed to change the name class on the fly between a namespace. Because if you look at, you can see that under, I think that's under like assignment or something. Yeah, so here, so we can see that between a ref, so that's what we have, an object, and a variable, we can change the value, and we can change the value between functions and operators, but we can't go across that. So we just need to eradicate that name from the symbol table before we do the fix. And we don't actually need it anymore. The only thing we wanted to do here was to get the name of that's inside it. Which actually we could probably have inferred. Now we needed to get the syntax here. Here we didn't. It's good enough. So we just do an ns.quadex on the name, and that should allow us to do it. Yeah. Actually, why am I even doing this quad fix? I should just set the source. Source right there, and then we do the source right there. Go and load on demand, and then my ns, and it gives us this. Okay, so definitely that worked. And then if I say r gets that, now what is r? It's this namespace. So my ns inside LUD has also been. Oh, it still looks like this. That's interesting. Huh. It's still a function. So why did that happen? That's interesting. We fixed that. So when we run it, oh, I know why. It's because it's local. Right. The name itself is local, which was fine when we were just passing a value through because we were calling it. But in this case, we need to make a global quad fix outside of this capsule. So we need to get rid of the name here as well. So we need to say quadex on the name, like that, and that should do it. Maybe I should split this over multiple lines. There's no reason to do it like this. Okay. So let's try to do this again. If the first ns.quadfix creates a namespace with the correct name, can't you populate that namespace with the correct contents? Sure, I could, but okay. So we could do a namespace, and then populate it with the correct content. But using load on demand, sure. Ad infinitum, right? Because what if part of that namespace consists of namespaces? And so we would need to traverse all of those and do load on demand on every sub thing inside. Yeah, right. Or stubs or something. But there's a problem here. And that is that it could be scripted namespaces. And so if you ask for if I populate the namespace with stubs, then we never get the actual script in there in the proper way. But this should work. So let's see. And we can see we got this namespace, and then if we try to edit here, lud.myns, ooh, it still says that. Huh. So that's going to read that file every time. Why? That's interesting. I thought when we ran this, we eradicate that. Oh, I think the problem is when we return it. It's actually still shadowed. Even if we erase it, it just deletes the value, but it's still shadowed. So we have to return a different name for the return variable, and that doesn't actually matter so much because we're not going to shadow out anything. It's just a one-time returning thing. Okay. So that didn't do it. We don't actually need that. What we do need is we'll just choose a return value that it has to be a name that is different from the original name. So we can do that. It can be do a trick here, like that, or like that. That'll do it. That'll just add one more character, so they must be different. And then this returns a name, so we extract that. This is dangerous because we don't know what QuadML is going to be. So this could mean mix, and that's not good. So what we want to do is we want to make sure to we can just flatten it. Oh, we don't know that either because maybe QuadML is 0. Okay, so what we do is we make it into a scalar instead of a vector, and then we can join the inner and outer axis. That's fine. So if it mixes, it's fine. If it's first, it's also fine. And that returns the name of the thing that was. Oh, we already know what the name is. Oh yeah, we don't have to worry about that. So we can just say source gets and then the result variable is name followed by delta, say, gets, and then dereference the name. I think this should work. We'll try it like that. Oh, domain error, -ns. Oh, of course not. This is already. Ugh, stupid me. Of course, we not. It's not an expression we're executing. It's just literally the name like that. So that should be fine. Okay. I wonder if this will actually overwrite it. This will be interesting. This gives the result like that. But this is. Oh yeah, no. See, that works. Because now it's. You can overwrite the function itself, but not the result variable name, I guess. Yeah. Doing interesting things here. So there we go, I think. There might be an interesting. Oh, right. Here's an interesting little thing. What if you have a class and you have a derived class and we didn't actually load it? That might fail. Because even if we ask for the value, that will load it at that point. But if we try to instantiate a class that's based on a different class, then we didn't ask for its value. So I'm not sure. It might just have to be a restriction that you can't do classes like this. But we can do namespace. We can do functions and operators. And we can probably let's do arrays now. Why not? We can probably do arrays as well. In that case, we have to go completely different route because we can't do quad fix at all on it like that. So and the only way we can know something is an array would be by looking at its extension. So quad n parts on the file, and then we want. Oops. I should probably also go and set QuadML here, just to be safe. Ugh, that doesn't look very good, does it? See, the reason we have these locus lines is so you can organize yourself. So we want the last part is the extension, and then that's going to be APLF. So if that's a match, then we've got an array. Else we're going to do all of this. And if it's an array, then we want to build a stub. There has to be a transform because it has to be niladic. So we're going to say that the source is name. Yeah, no, I don't have a typo with quad.io getting 1 because I like using quad.io getting 1. You're welcome to use whatever quad.io you want. It's a free world. Yes, that's an actual typo. That I have to. It should have been like this. That's right. And in fact, I mean, the only thing that matters with quad.io here was. Did I even use quad.io? No, I didn't. Did I? That was in the old version. The old version over here. This guy. Here we use the 2 pick each. So rack 1507, you have a mistake. It's not that I used quad.io 1 instead of quad.io 0. It's that I used anything that refers to particular indices at all. Let's do array programming. We don't need indices. We do the whole arrays instead, right? Okay, so we're going to create this stub here, and we're just going to have that. And then we need the value. So I think what we're going to have to do is something similar to this down here, actually, in order to avoid localization problems, which is not a problem, right? So we're going to erase. The function erases. So notice this is a function erasing itself, right? We just did it, but it's not actually so obvious that a function can erase itself, but in APL it can. And then we are going to take the file name. So we're going to take something like this, like we had before, but we don't need file colon now. We just need quotes around it, and we're going to do a quad n get on that. The first here is so that we get just the content. We're not actually interested in what's inside and what the encoding is and the line endings and so on. And that's going to be the value of that. I'd like to do an experiment whether this would. Oh yeah, there's a function to an array, right? So we have to do it like this. Okay. So then we say name assigned this. Hold on, is this right? Oh yeah, right. This is not how we want to do it. Like that. And then the return variable is going to be the same thing as down here. But of course we don't just want that. We want to deserialize it then at that point. So I'm using version 18.1 already, and the array serialization stuff has moved. Well, let's give this a try. Again, real programmers use Notepad, right? Okay, so let's create a matrix like that. You predict it won't work. Thank you for the confidence. I didn't actually run it yet, but just wanted to see whether this works. quadc.dialog.array .deserialize pick quad n get temp load my r dot API. Yeah, I think it's because we need. There you go. So we just need to do it as a vector vectors. So that's in here. Let's see how exactly it needs to look. Yeah, I'm not done yet. Come on, hold your horses. I'm not. One thing at a time. And we need the one over there. Okay. Okay, so you still predict that this won't work? Let's try it. I'm not afraid of not working. It's not a compiled language, it's interpreted. It's really quick to try things out. Lud dot. Oh, so you're right, it didn't work. Let's step through it and see what happened here. Okay, so that's the first one there. And the second one, it's not APLA. Oh, okay, so now we're in the APLA. Oh, I know why it's not working. Duh. Of course. The reason is we never fixed the source here, because this needs to be outside the if, because we are going to fix it, because it's a function even though it's an array, if that makes any sense. Okay. Now, moment of truth. Didn't work. Okay, let's try that again. Actually, can I be clever here? What happens if I rename this to A? And get rid of that underscore. Will it go first now because it's alphabetical? No, it didn't. I wonder what files is. A-my-ns. I renamed the wrong file, didn't I? I did. So much for that. Yeah. Now it's the first one, isn't it? Oh, undefined name. Yeah, of course it is. Because what we did here was we loaded this up. So what we need to do is, when you do the quad n parts, do we want to do path, name, and extension? Gets that. Oh, path not a good variable to use. I guess it doesn't really matter, but we call it location instead. Okay. Now it looks better. What does the source look like? So we get that array, erase our own name, deserialize after loading that whole thing, then assign that to itself and return that in the return variable. We could combine those two lines, but it doesn't matter so much. Okay. Dot myArray. That's this function. But if we ask for its value, it's a matrix. And what if we go and look at it again? It's now a matrix. So it works. Look at that. Load on demand. I'm a little bit concerned about here. Didn't I link this? Maybe I didn't. I should save this. Where did we put it? dlun. Oh, okay. Oh, I did put it there. Okay, so I think we got load on demand done, basically. I mean, there's some stuff that could be done here. Yeah, could this be used for something like PCO to load in pre-computed prime numbers only when they're needed? Absolutely. I mean, in this case, I loaded from source files, which is where I really would want to keep things, I think. I could potentially have copied them over from from a workspace as well. A benefit of the way I'm doing here is, even though I might load in a big thing here, it immediately, every time we around the loop, we immediately go and replace it with something small. So we never have more than one function or operator, whatever it is, in memory at the time. But hey, good question. Can we do this with defense? Let's try it. Okay, so let's see. So we got now this guy here. We don't need this goo anymore. Okay, let's clear the workspace. So defense is currently a workspace, but let's try to make defense into a scripted namespace instead. Do I have something called temp defense? No, I don't. Okay, that's great. That's exactly what we need. So let's load defense, and then we're going to try to export hash to temp defense. I wonder if this will work. Who knows? Yeah, look at that. It worked. Okay, so if we go in here and temp defense, so now the whole defense workspace has been converted to text files, right? Including PCO. So I bet if we look here at PCO, it's 43 kilobytes, which is probably like the biggest one. Yeah, bigger than the interpreter for the Java language. So the question is, would you want this cached or not? So right now, what we're doing is we're immediately, the first time we call it, we cache it, but we didn't have to. We could have done that with just called it instead of replacing it. Okay, so now let's clear the workspace, and then let's load in this guy. And then let's make a defense namespace, and then we say defense load on demand temp defense. Ooh, unable to open file, access denied. What file is that? Oh yeah, of course. I know what the problem is. The problem is that it's a directory, and we've got lots of stuff in that directory. I didn't quite do that right. We don't want those extra things. Those are all the documentation that you find on the defense website and test scripts and stuff. We're just gonna get rid of that. We don't want that. Okay, let's try this again. So here. Oh, that was really quick. Look at that. Wow. How long time did that take? No, I don't know if that's a good idea. Sure. Oh, won't hurt. We can try it. Okay, sure. 1/7 of a second or so. That's not bad. So now we've got defense. Let's see. We've got them all. Look at that. PCO. That's a very manageable PCO. The existence of folders in the directory that you try to is still valid. Yeah, it's a valid concern, and it's a bit of a question. Should we traverse all that and build the whole structure or not? Currently, the way we load things into Quad SC, it doesn't actually traverse folders, and link does. But traversing folders is not a hard thing. It's a standard kind of thing. We can always add that. The important part I wanted to do here is just the load on demand. So PCO, there we go. We got it. Anybody remember what the calling syntax is? That means it's a prime. Yeah, it's a prime, right? And that's not a prime. Did you know that's the last prime before a million? No, right. Okay, so we can easily yeah, exactly, yeah. I know. And 1e6, it is the last prime. It currently crashes on them, but we can easily fix this, right? The important part is when I listed all the names here, I didn't filter them first. So the way we would filter them, and why not? Let's fix that. So 0 is the default, that's the name, and 1 is the type. So we just want regular files, type 2. Okay. So we say 0 and 2. So that gives us the files and the types. So let's try that. So we go over here and we do an undo on that. So now we have these again. And then start tracing into that. So we got the files and we got the types. Ooh, that's not right. Oh, I typed 2 instead of 1. Okay, so and then at the end I give it. Well, maybe we should have some type 1. Those are the directories as well. So we will simply filter the files. So files gets 2 equals files, like that. No, that's not right. Of course not. Types. Okay. So now, okay. Roger GS, you happy? It now doesn't crash on the on folders. It just ignores them. And there's more. There's more to it than that, right? We really should filter even more, because what happens if it's not an APL file? So really, what we should do is we should go and say, put end parts on the files, and take this. Now we need. Actually, we don't really need that, do we? So the last name of each here, and then we want to check whether they are members of .apl. Actually, we can do it like this instead. Member of .apl, comma, each of array function operator namespace. Maybe it's safest to ignore classes and interfaces, but I don't know. Fancy. Like that. I mean, it could really be .dialog as well, I guess, if anybody wants to use that. .dialog. Okay. So, if they're a member of that, then we keep them. Like that. Ooh, what happened? Length there. Oh yeah, of course. It's missing a jot. There we go. So this will allow us to have all kinds of files in there that we're not interested in. These are the file types. Right. Any issues? Any questions? Here, I think this just works. So I should make sure to save this. I keep forgetting that I should link it to that. Oh, I mean, I'm tracing. That won't work. Save as. Yeah, stay there. I think we're good. I think as a prototype, this works quite well. And there should be no name clashes because we're always doing things inside the that namespace over there. Actually, what we could do, we could actually be clever. I'm worried about these classes here. We can try it out and see what happens. Where do we go? Temp load on demand. So we have this namespace here. Let's try to copy that a couple of times. We're going to write my class 1, and my class 2, and then let's edit that. Class. Okay. And then I should have copied that. This is my class 1. And then my class 2. We're going to base that on my class 1. So this will be interesting. Okay. So if we say, actually, what do we even have here? We could just do it in hash. We haven't even tried using hash. It should work the same. Load on demand from temp. Actually, still have this load from before. Temp load. Oh, we didn't. Okay. Load. Create that. Right. That's exactly what I was looking for. Right. Invalid base class or interface declaration. We can't do this because we're missing the base class. No, but I thought there was an option. I think there's an option. Oh yeah, no. I think that's like a hidden like an unofficial option. quadc.link.fix. Does this? No, that's not where it is, because it's inside like u.fix. Yeah, see? Yeah, I'm teaching you secrets here. So there's actually a variant on fix that's not official, which is that it allows you to do all these. Oh, I wonder what that is. Link. Oh, right. So these are all kind of tricks that Link uses to to decide what fix should use. That's another thing we didn't speak about. The interpreter is going to associate these things with the file, and we might not want that actually. So we probably want to use the same kind of options here. Quiet means don't show stuff in the status window. Allow late binding. That's exactly for that thing with the and fix with errors. I don't know. Do we want to fix with errors? That I'm not sure. Oh yeah, maybe because it refers to other things. So that we should probably all just copy all of that. So in here, we just put all that in. Right there. And do we want to link it? No, we don't want to link it there. Okay. Yeah. Yes. Ah, okay. So now load.class2. It's this, right? The question is now, okay, so if I do class 1 and I try to create a new one of those, that created a new instance of class 1, and then class 1 became the real thing. If I want to do a new class 2, that works as well. Okay, so now let's load everything in on demand again. So now class 1 is back to being the stub function, and class 2 is the stub function. And now we try to instantiate class 2. Bam. It doesn't work because invalid base class or intervalid, because we're trying to do something with a base class that doesn't exist yet. And even if we defer, it's too late. It doesn't help. Right? Even if we try to go in here and say we want to do that with errors, it's not gonna help us because this only defers all these options that we put in. It only defers the base using the base class until we instantiate. But instantiating is exactly what we're gonna do. So the only thing we could do that here is by analyzing the class to see which dependencies does it have, and then go in and load all those things as well. So I think what I do here is I'm going to say I can load on demand other things, but I can't load on demand interfaces and namespaces. So we're going to get rid of those here. Oops, that doesn't look right. And add those down here. Case list. And then and I mean we probably should add also some an error trapping here for this quad fix, just to make sure, like in case the file contains garbage and we can't actually fix it or even figure out what it is. So for these, we probably want to do nothing actually. We can even just leave out this case thing. We don't even need it, because that would just mean we just fix them in and we just leave them the way they are. We can't late we can't load on demand when it's objects with potential dependencies. That won't work. Okay, so let's put in a trap here. Trap, what does quad fix even give? I mean, it doesn't really matter. So trap 0 else, and then we can give him should we continue or not? We probably want to say that it failed, right? Could not fix and then the file name or something. Right, we have a file like that. Okay, so now we can go in here and create another file that contains garbage. That's certainly not valid. And then we can try running it. Yeah, okay. So, but it did load everything else, right? Didn't it? It did. And my class now gets loaded in as its full thing, so no issue there. Should we warn about classes? Maybe. So we can go in here and say, actually these should really go to standard error, shouldn't they? Because they're error messages. Something like this. It was fully loaded, huh? Okay. That's nice, isn't it? Yeah, that's it. I think we're done for today. Any questions? Anybody has any comments on this? Otherwise, I think that's it. We've got a load on demand for APL. And I just need to go to management and see what they think about it. If it's something we want to ship and use, or maybe make it an option. when you do the session startup, maybe it should be some kind of option to load on demand instead of loading everything in at once. So. Okay, thank you so much for watching. Maybe if this was something you like, then maybe we'll do more live streaming coding stuff like this. So take care.